Okay, so in this video we move into the very last part of the geometry and measurement module, which is to look at the geometry of spheres and more specifically the geometry of the Earth as an example of a sphere. So this is, I think, quite an interesting component of the course, but for some students it is quite difficult. It does rely on some quite good spatial awareness, and I would encourage you to, get your Google Earth up on your computer screen. If you can, get an actual globe that you can see and touch and move around and feel and point to and whatever, so that you can actually see what's going on here. In the classroom I like to have a globe when I'm teaching this particular topic, but for now we'll have to make do with Google Earth, which I'll flip over to for a minute. So we're going to be looking at the Earth, and for mathematical purposes, the Earth can be modelled by a sphere. It's not a perfect sphere, but it can be modelled by a sphere with a radius of 6,400 kilometres. Now in further maths we'll use 6,400 kilometres as the radius of the Earth. It's actually closer to 6,378 kilometres, and obviously that's not exact either, but for all intents and purposes in further maths we will always use 6,400 kilometres to model the radius, and the questions will always state that quantity for you. So given that information, if we're modelling the Earth by a sphere with a radius of 6,400 kilometres, we want to use this fact to calculate the surface area and the volume of the Earth correct to the nearest whole number. Okay, so this is just our formulas to do with spheres. So we know that the surface area of a sphere is 4 pi r squared. So in this case that is 4 pi times 6,400 squared. Okay, so in my CAS, 4 times pi times 6,400 squared. So that's exactly that many times pi, which as a decimal is approximately, what have we got there? Where are our millions? 514,718,540.4 nearest whole number, so 540 square kilometres for the surface area of the Earth. And then for the volume of the Earth, volume of a sphere is 4/3 pi r cubed. So in this case that is 4/3 pi times 6,400 cubed. So let's calculate that. 4/3 times pi times 6,400 cubed. Oops. Cubed. Control enter. Sorry, control enter. Okay, now we've got this E here. That's just because it's a really large number and my CAS is truncating it because it can't fit it here. So I'm just going to scroll up and press enter to put it down on the next line so I can see the number more fully, and there I can see that I'm going to be able to give it to the nearest whole number, and it is really big. Let me just say 1, 2, millions, billions, trillions. 1 trillion 98 billion 66 million 219,440, now to the nearest whole number, 444 kilometres cubed for the volume of the Earth. So it's a big place. Okay, let's get into the geometry of it, which is what we want to look at over the next couple of videos, and how we describe positions on the Earth. So I'm just going to jump across to Google Earth for a minute. Just give me a second. Okay, so here we are at Google Earth. So you can probably tell from where the sun is that it is... oh, actually, no, I lied. It's okay. Ignore what I was going to say. So the Earth, you can see I've got Google Earth set up with the lines of longitude and latitude, which is what we want to look at in this video. We want to come to understand sort of how they work and how we use that sort of grid system. We're essentially putting a grid system on a non-flat surface, so that's a bit problematic. So we need to understand how that works. So the horizontal lines, we'll talk about this when we go back to the notes in a minute, are called lines of latitude or parallels of latitude. Okay, and they're measured relative to the equator. So the equator is that big solid line you can see sort of happening there. It's labelled as equator now that I've zoomed in. It's that big solid line that you can see going through the middle of the Earth, horizontally through the middle of the Earth. And the lines of latitude are measured relative to that. So you can see here we've got the label of equator here. So I haven't got a very good pointer here, so hopefully you can see me moving around that there. And then this next line of latitude up here is labelled as 10 degrees north. So that is 10 degrees north of the equator. And that 10 degrees is the angle that's actually subtended at the centre of the Earth. I'll show you some diagrams in a minute where you can see what I mean by that. Whereas the line below the equator is 10 degrees south. So obviously we measure in an angle away from the equator, so we could measure, if we could measure 90 degrees north, that would take us right up to the North Pole. If we could measure 90 degrees south, that would take us right down to the South Pole. Then we also have these vertical lines, okay, they're called meridians of longitude, okay, or lines of longitude, and they obviously allow us to measure the east-west position, okay, whereas the lines of latitude allow us to measure the northwest position. So you can see there's, like the equator is a bold line, you can see there is also a bold vertical line here. And we call that, let me see if I can zoom to a point where it will tell us what that's called. Tell me if I go up here. Yep. So you can see there, that bold line is labelled as the prime meridian. And the prime meridian is essentially like the y-axis for the globe, okay? So if you think about the equator as being like the x-axis for the globe, the prime meridian being like the y-axis for the globe. So all of the lines of longitude, the meridians of longitude, are measured relative to the prime meridian. And the prime meridian is the meridian, and a meridian is the word we use to talk about a line of longitude, okay? So the prime line of longitude is the line of longitude that goes through Greenwich in England, okay? So all longitudes are measured relative to Greenwich, England, okay? So roughly London, England. And they're measured either in an east or a west direction. So lines of latitude will be measured in a north or south direction relative to the equator. Lines of longitude measured in an east or west direction relative to the prime meridian. Okay, so you can see as we head out to the east, we've got 10 degrees east, 20 degrees east, 30 degrees east, etc. And if we were to actually look at the globe right from the bird's eye view, it's essentially, that 10 degrees is essentially 10 degrees measured here at the axis of the Earth, at the centre of the Earth, okay? So if you take the angle going along the prime meridian to the centre, to the North Pole, and then back out along the 10 east meridian, the angle that you've subtended there is 10 degrees. If we were to travel along the prime meridian to the North Pole and out here along the 100 degree east meridian, the angle that we've subtended in the centre there is 100 degrees. Again, I'll show you some diagrams I can draw on to be clearer where I'm pointing. And obviously if we go out in the other direction, so if we go from Greenwich, London, so from prime meridian out across Europe, we're heading in an easterly direction, and then if we instead we go out across the Atlantic towards the US, we're heading in a westerly direction. Obviously we get this point around on the other side, which is both 180 degrees west and also 180 degrees east. Either of those technically are the same thing, and we call that line the anti-meridian. And I think if I zoom, it'll tell me that at some point that it's called that. We'll spin around to the other side. It's called the anti-meridian on the other side there, okay? And so there you go, anti-meridian around here. And so we've got this grid system on which we can measure positions on the Earth. So for example, down here in Australia, where we are, we can zoom in here and we can see roughly what our position is here in Melbourne, Victoria. Given we're studying further maths, we're all in Victoria anyway. But if we think about Melbourne, we can see that we are roughly on the 145 degrees east. Sorry, I lost that line, just that label just then. You can see 144 and 146, so we're roughly on that 145 degrees east meridian of longitude, and we're roughly on the 38 degrees south line of latitude. Okay. And so any point on the globe can be pinpointed using this grid system. Okay, I'm going to go back over to the notes. Okay, so as we saw on Google Maps, we can describe the location, so that we can describe the location of points on the surface of the Earth, we use a grid system comprising lines of longitude and latitude. Lines of longitude, as I mentioned, are called meridians of longitude, and they run vertically from north to south. Okay, so each meridian of longitude is a semicircle. So it's a semicircular arc running from the North Pole to the South Pole around the surface of the globe. Okay. Longitude is measured in degrees relative to the prime meridian, which remember I said is the meridian that runs through Greenwich, England. Okay, so all our east-west positions are measured relative to there. So if we imagine here, we've got down here the Earth, if we look at it from a bird's eye view, so from directly down from the North Pole as we just did in Google Earth, we're going to have our prime meridian running through Greenwich, England, and then we're going to measure our longitude in an easterly or westerly direction. And so you remember we just saw that the that Melbourne was on a roughly 145 degree east line of longitude, so that's going to be sort of somewhere around here is where we are compared to England, okay, or compared to London. So you can see, so as I said, those angles, if this is 45 degrees east, it's because that's our prime meridian into the center of the Earth at the North Pole, out to the 45 degree east meridian, we create a 45 degree angle in the center there. Okay, so when I talked about Melbourne being roughly around here, that would be where we've created a 145 degree angle in an easterly direction from the prime meridian. So hopefully that makes sense. I'll just show you this other diagram in a minute. Okay, so here's a sort of stylized version of the globe. If we imagine, if we imagine that, sorry, it's hard to control with my touch screen actually. There we go, come back. Okay, so if we imagine that the red line is our prime meridian, so it's a semicircular arc from north to south, and that's where we're measuring our longitudes from. The blue line is our equator, so that is a circle going around the widest part of the Earth at the center, and all of our lines of latitude are measured relative to that. Okay, so our North Pole would be up there at the top on the axis of the Earth, and our South Pole down at the bottom on the axis of the Earth. So hopefully you can sort of get a sense of what's kind of happening there. So we were just talking about lines of longitude. So we can see our red line being our prime meridian. If we were looking at a line of longitude, that's sorry, I should have left that angle labelled, that's a 45 degree angle. And so therefore, any position on the Earth that is down this edge of this dark blue sort of sector that's been cut out, any place on the Earth down there would be at a longitude of 45 degrees east. So it's 45 degrees east of the prime meridian at that location. Okay, so lines of longitude, and then we also have lines of latitude, which we call parallels of latitude, so meridians of longitude and parallels of latitude. Parallels of latitude run horizontally in an east-west direction, and each parallel of latitude is a circle. Okay, so you imagine sort of slicing horizontally through the Earth, the cross-section that you're creating is a circle, the parallel of latitude, the line around the circumference of the sphere is a circle. The parallel of latitude with the same diameter as the Earth is called the equator. So that's the biggest circle we could possibly draw on the circumference, on the surface of the sphere. And so that's the equator. And then all other lines of latitude are measured relative to that equator. Okay, so latitude is measured in degrees relative to the equator. So the equator has a latitude of 0 degrees. The North Pole has a latitude of 90 degrees north, and the South Pole has a latitude of 90 degrees south. Okay, so here, for example, in this 3D diagram that I've got here, you can see that I've got a parallel of latitude at, sorry, I'm just trying to fix my pens all over the shop here today. Alright, here in this diagram you can see that I've marked a parallel of latitude at 24 degrees, okay, 24 degrees north I should say. So that is when we go from the equator into the center of the Earth, okay, so into the axis of the Earth at that same height as the equator, and then look at what is the angle we have to look up. So I guess it's sort of an angle of inclination or an angle of elevation from the equator. We're going up by 24 degrees, and so therefore that is at 24 degrees north. So any place on the globe that lies on this circle up here that's 24 degrees north of the equator is on a parallel of latitude at 24 degrees north. If we have a look at this diagram here, this two-dimensional diagram, this is where we imagine sort of slicing vertically through the Earth, so we can see it in the lines of latitude in a two-dimensional representation. So you can see here that you've got your equator, and then all of the lines of latitude are measured relative to that equator, and it is about the angle that's created at the center of the Earth. Okay, so that's a 30 degrees north. Okay, going from here down to here this is 50 degrees south, because that angle in there is 50 degrees below the equator. Okay, so the North Pole has a latitude of 90 degrees north because that is 90 degrees. Okay, whereas the South Pole has a latitude of 90 degrees south because that is 90 degrees that way. Okay, so, if we wanted to measure a latitude of 70 degrees north, we would be going from the equator, subtending an angle of 70 degrees up. And so this parallel of latitude up here is the 70 degree north parallel of latitude. So hopefully that makes sense. So for example, as we saw on the Google Maps, Melbourne, Australia is located at 38 degrees south, 145 degrees east. And this means that we are located 145 degrees east of the prime meridian and 38 degrees south of the equator. So you can see that represented here in this diagram. I'll just go to a 3D version of that so we can sort of see it in motion. Okay, so here we have that same diagram. Oh, sorry, again, it's difficult to control these diagrams on the touch screen. Alright, so here we go. Let me just use the mouse so I can control it a bit better. So we've got our prime meridian is this solid blue meridian, and our equator, the solid blue circle around the center of the Earth there. So we can see that we've got our 38 degrees south. So if I were to turn this diagram, sorry, there we go. So it's sort of straight on. We can see that we've dropped 38 degrees south of the equator, but then we also have to go, if we look at it from the top, 45 degrees east of the prime meridian. So we've got those two quantities, how far south we are and then how far east we are, to locate our position relative to essentially this point over here that I've got my mouse hovering over. That's essentially the origin of the Earth. That's basically where the prime meridian intersects with the equator. If you think about a set of axes, that's like the origin. Everything's being measured relative to that point, really. How far south of that point are we, and then how far east of that point are we? Okay, let me go back to the notes. We'll just have a look at a couple of examples to finish. Okay, so here we're going to use this information in this table to answer the questions below. So we're given a number of cities around the world and their position in terms of their latitude and longitude. Okay, so the first question, question one is, which cities are on the same meridian? So remember, meridian is to do with longitude. Okay, that's the vertical lines. So we want to be looking at which of the cities are on the same longitude, and in this instance we can see that both Cape Town and Budapest are on the same longitude, and also Naples and Prague are on the same longitude. Okay, so we're going to have Cape Town and Budapest. They're on the 19 degree east meridian of longitude. And then we also have Naples and Prague. Oops. Naples and Prague. And they are on the 14 degree east meridian. So actually not too far apart in terms of their easterly direction. So if 2 points represented these cities, now actually I think I intended this, let's do this, we'll have to do this twice. If 2 points represented these cities, what would be the angle subtended between them at the centre of the Earth? Okay, so now what we want to be able to think about is, let's have a think about Cape Town and Budapest. Okay, wherever they are in the Earth, they're vertically above each other. Okay, so we already know which one's which. So Cape Town is 34 degrees south and Budapest is 47 degrees north. Okay, so if this is the equator, that's the centre of the Earth. Let's have the equator. Then Budapest is 47 degrees north of the equator. Okay, so that would be where Budapest is. And Cape Town is 34 degrees south of the equator, so not quite as far south as Budapest is. So this is Cape Town down here. Okay, so the question is, if two points represented these cities, what would be the angle subtended between them at the center of the Earth? Okay, so they're vertically above each other, so there's no angle subtended the other way, but they're going to subtend an angle. Okay, so the angle subtended is going to be 47 plus 34 degrees, which is 81 degrees. Okay, and so you can see here we're leading towards actually being able to calculate distances using our arc length calculations. So we could therefore work out what is the distance between Budapest and Cape Town if we were to travel vertically, directly north or south, okay, by using this arc length and using the fact that we know that the Earth has a radius of approximately 6,400 kilometres. So we'll get to that in subsequent videos. So the second part B, we've got Naples and Prague. We see that they are both north of the equator, okay? So it's really important that you kind of think about a diagram rather than just come up with a general rule of, oh, to work out the angle between them, you add together the two angles. We added together those two angles because one was south and one was north, okay? Whereas these two, when they're north, we're going to need to do a subtraction. So we need to think about what's happening here. So essentially, these are both above the equator, okay? They're on the same, sorry, let me make that a bit smaller, we'll run out of room. They're on the same meridian of longitude. If we think about that's the North Pole up there. Okay, so this is our equator. This is the North Pole. Okay, this is the center of the Earth here in the middle. So what we know is that Naples is on this, and this is the 14 degree east line of longitude, essentially, is what that arc length represents. So Naples is 41 degrees north. Okay, so we're going to have Naples, let's make that a bit bigger than that. That's about maybe 41, it's maybe a bit small, but anyway. So that's going to be Naples. And then Prague is another 10 degrees higher than that, or 9 degrees higher than that, at 51. So in terms of what is the angle subtended at the center between these two cities, if we travel from Prague into the center and back out to Naples, we get this angle in here, which is a 10 degree angle. Okay, sorry, not 10, it's roughly 10, sorry, 9 degree angle. Okay, so the angle subtended, in this case, because they're both north, is actually the difference between, sorry, I got those angles wrong, haven't I? That's 50, is actually the difference between them. So it's 50 minus 41, which is 9 degrees. So it's really important that you think diagrammatically, that you draw pictures, and that you be clear about what's happening. Okay, question 2 asks, which cities are on the same parallel of latitude? So if we think about the parallels of latitude, so that's their north-south measurement, we have 2 cities on the 34 degree south parallel of latitude, and we also have 2 cities on the 41 degree north parallel of latitude. So we have Sydney and Cape Town, are both on the 34 degrees south parallel. And we also have New York and Naples on the 41 degree north parallel. Okay, so if 2 points represented these cities, what would be the angle subtended between them at the north-south axis of the Earth? Okay, so we need to do them separately. So we need to think about Sydney and Cape Town over here on the left. So Sydney and Cape Town are both south. Okay, so this time, rather than looking at the Earth by slicing it vertically, we now want to look at the Earth slicing it horizontally. So we want to think about, we've got that circle that is at the 34 degree south parallel. Okay, we've got the center of the Earth happening in the middle. Okay, and we've got our prime meridian. Let's, for all intents and purposes, let's put that maybe here. Okay, so let's say that's going to be our prime meridian. Okay, so we need to think about their longitude. So Sydney is at a longitude of 151 degrees east, and Cape Town is at a longitude of 19 degrees east. Okay, so we're going to have Cape Town there, and that's 19 degrees, okay? And then we're going to have Sydney out there, oops, and that angle all the way around there is 151 degrees. Just check I got that number right, yep. Okay, so that means that the angle between them, if we go from Cape Town into the centre, back out to Sydney, that angle between them is going to be the difference between those two. So the angle subtended at the centre, so subtended, is going to be 151 degrees, take away 19 degrees. Sorry, I should have done that in my head. 132 degrees. 132 degrees between them. And again, you can see how we would then be looking at potentially calculating the distance between Cape Town and Sydney along this parallel of latitude. The difference here is that the parallel of latitude is, the radius of that parallel is smaller than the radius of the Earth. So it's some extra calculation to work out what the radius of that parallel of latitude is. And then the second example, New York and Naples. So now we're on the 41 degree north parallel. Okay, again we've got the center of the Earth. Let's put our prime meridian here for all intents and purposes. You can draw it wherever you want. And so New York is 74 degrees west and Naples is 14 degrees east. Okay, so this time we have Naples is east. Okay, so that's 14 degrees there. And New York is 74 degrees west, so it's going the other way. So New York is out here. Let me just get rid of that 41 out of our way. Put that anywhere. Struggling. Okay. Alright, so this is New York. And that angle from the prime meridian around to New York in a westerly direction is 74 degrees. And so therefore the angle subtended, in this case we're going to need to add them because they're going in opposite directions from the prime meridian, and so we're adding them together to work out the angle between those two cities. So if we were to go from Naples into the centre and out to New York, that angle that we subtend is going to be 14 plus 74, so that is 88 degrees between them. And again, we're going to need to be able to work out those angles when we want to start to calculate distances between these cities, which we'll do over the next couple of videos. So the work today is in exercise 19b, questions 1 to 3.